section 4.4. In this section, we're going to learn to perform operations with pure imaginary numbers, and we're going to perform operations with complex numbers. Some of the vocabulary that you need to note down, and as we go through the videos, make notes on are imaginary unit I, pure imaginary numbers, square root property, complex numbers, and complex conjugates. So let's start with looking at a quadratic equation. So we talked about in the last section what the roots of a quadratic function is. It's where it crosses the x-axis. As you notice, this quadratic equation has two roots because it crosses the x-axis in two places. This one has no real roots or solutions because it does not cross the x-axis. Well, this led to mathematicians to come up with what we call imaginary unit I. All right? Imaginary unit I is defined to be I squared equal negative 1. I is the principal square root of negative 1. That is, if I took the square root of negative 1, that's what I equals. So if you have the square root of negative 1, you can replace it with I. Pure imaginary numbers of the form 6i, negative 2i, and I square root of 3, these numbers are square roots of negative real numbers. So for any positive real numbers, b, we can say the square root of negative b squared equals the square root of b squared times the square root of negative of I, or negative 1, which we can equal square root of this is b, square root of that, we said the square root of negative 1 is I, we can say it's bi. So let's look at that. So let's just look at an imaginary number. So if I have the negative 27, I can break this down to say negative I times 3 squared times 3, right? Because the property that says I can do this says you must have the same index number, which they all have an implied 2, then I can break them up or put them back together. Because 3 squared is 9, times 3 is 27, and this is not I, this is negative 1, sorry, is negative 1, which all results in negative 27. So now we said, what is the square root of negative 1? It's I. And this becomes 3, but I'm left with square root of 3 because that's not a perfect square. I can take those out and I'm left with this, so it's simply going to be 3i square root of 3. Let's look at another one. What if I wanted square root of negative 216? Well, we can break that down to say negative 1 times 6 squared times 6. This all equals that. So we know this, we said square root of negative 1 is I, square root of 6 squared is 6, left with square root of 6. And there is my solution. Right? Now, can we do the product of pure imaginary numbers? Sure we can. So if we have negative 5i times 3i, well, this all means multiplication, so I can start with using the real part. Negative 5 times 3 is going to be negative 15. And I times I, remember they're the same, they're bases. It's like if I had x times x, and they're implied to the first power, that equals negative 15i squared. Now, I squared is equal to negative 1. That's important to know. Because we have I, we said is equal to negative square root of 1. And if I have it squared, it's times negative 1, which I can put under here to say negative 1 square. And the square root of that is negative 1. So then I can replace this. So negative 15 times negative 1, and I get 15. Let's try another one. Can I do negative square root of 6 times square root of negative 15? The rule for multiplying is you just have to have the same index. I do. So then I have the square root of negative 1 squared times 15, or I can look at it this way, or I can look at it as negative 1 times 6, square root of 6, times square root of negative 1, times square root of 15. So we know this is I, and this is 3 times 5, and this is I over here. And then I can put these 2 times 3 times 3 times 5. I can take out a 3. I times I is I square. So I have 3I square, square root of 10, because that's what's left. And we said this is negative 1, so I have negative 3 square root of 10. I can look at it that way, or I can break it down to say negative I times negative I times square root of 6 times 15 all under 1, and then solve it that way. All right? So what is the square root property? Let's look at what the square root property says. It says you can solve some quadratic equation by using the square root property. We can do the same thing when we're solving for imaginary numbers. So let's look at this one. X squared plus 64 equals 0. How do we solve that? We use algebra. So we have x squared equal negative 64. You take the square root, x equals plus or minus the square root of negative 64. But what's the square root of that going to be equal? I and 8. So plus or minus 8i is our solution. All right, let's look at complex numbers. What is a complex number? That's when you have a real part and an imaginary part. So let's consider 2 plus 3i. 2 is real and 3i is the imaginary part, and they're not like terms, so we cannot combine them. So therefore, we say it's a complex number, and the standard form for a complex number is a plus bi, where a is the real term or the real part, and b is the imaginary term or the imaginary part. All right, so let's look at an example. It says find the values of x and y that make 3x minus y plus y minus 3i plus 7 equals 7 plus 6i true. So our problem is 3x minus 5 plus y minus 3i equals 7 plus 6i. We want to make that true. So we're going to set the real parts equal to each other and the imaginary parts equal to each other. So let's look at it, instead of as one equation, we're going to look at it as equation A and equation B. What is my real part? 7. What's my real part over here? Here. So remember, this is two terms and they're the real part. This is another term, but it's the imaginary part, just likewise this one. So we're going to say 3x minus 5 equals 7. We're going to solve, and x equal 4. Now we're going to take the imaginary part and we're going to equal it to the imaginary part. So I'm going to divide by I using algebra. Y minus 3 equals 6. Y equal 9. All right, so x equal 4 and x equal 9 are my solutions here. So let's use other operations. Can we add and subtract complex numbers? We sure can. So we have minus 7i. Again, we're just using some basic math rules for algebraic expressions and equations. So we have parentheses. Can we combine them? No. Is there anything outside to distribute? No. So we can break down these parentheses. And then we're going to combine like terms, is all we're going to do. So we have 5 and 2 are like terms, so that's 7. And then negative 7i and positive, it's like saying negative 7x plus 4x. So we're going to minus 3i, and there's our solution. It's in standard form. Let's try one more. 4 minus 8i minus 3 minus 6i. All right, so nothing out here. I can't combine this, so I'm going to get rid of my parentheses. But oops, I have a negative here that I must distribute to both terms. So minus 3 plus 6i. Now I can combine like terms, and I get 1 minus 2i. Because it's as far as I can go, it's in standard form. Let's talk about conjugates. What is a conjugate? Complex conjugates. So two complex numbers in the form of a plus bi and a minus bi are called complex conjugates. So let's use that to simplify. So I have 2i over 3 plus 6i. Well, I don't have an imaginary part in the denominator, so to get rid of it, I'm going to multiply by its conjugate, 3 minus 6i. In order to do that, I have a fraction rule, so I must do it to the top. So I just simply distribute. I get 6i minus 12i squared over 9. And when you do that, the OI's are opposite. Let's look at that. That's 18i and negative 18i, so they become 0. That's why you multiply by its conjugate. So you just really need to do the F and the L part of the FOIL when you multiply two conjugates. And then 6i times its minus 36i squared. And we can simplify. We have 6i minus, this is negative 1, so it's plus 12 over, this is negative 1, I squared is negative 1 times negative 36, so you have 9 plus 36. 9 plus 36 is going to be 45, and you can factor out, and then you have 6i plus 12. If you want to simplify and break this down, you can factor out a 3, and you have 2i plus 4 over 45, which is 1 and 15, and your final answer is going to be 2i plus 4 over 15. And that's as far as you can simplify it. All right. That is complex conjugates. That is complex numbers. I need you to do problem number 18 and problem number 36 on page 250.